Hey guys, we have a special guest here today. It's the one and only Mr. Rumpft.
Hey guys. Hello? No. All right. So, joke of the day. Heard this one on the phone today. Why did the Pilgrims sail for America in the spring? Anyone? No? Okay. Quiet group. Because April showers bring May flowers.
Ha ha ha.
All right, so I'm going to do another one. This is one of my favorite jokes. So there's a tray of muffins in the oven. And one muffin says to the other, "It's really hot in here." And the other muffin says, "Holy crap, a talking muffin."
All right.
Have a good
Thanks
day.
for our 2 jokes, Mr. Rumpft. Let's talk about natural log derivatives. All right. Well, that was fun. We are going to talk about derivatives of the natural log function. We just spent time talking about the derivative of the exponential function, right? E to the x. The derivative of e to the x is e to the x. Wonderful. So let's talk about what's the derivative of the natural log of x. Now, there are many proofs to explore on this. Unfortunately, we won't be doing that. But what's important for us to know is that the derivative of the natural log of x is 1 over x when x is greater than 0. Now, you might be wondering, well, what's up with this x is greater than 0 part? Well, think about what the domain of natural log of x is, right? And maybe it helps to imagine what that graph looks like, right? So the domain of the natural log of x is 0 to infinity, or x is greater than 0. So that same thing carries with the derivative. Okay? Keep that in mind. Now, what happens if it's not just x? Just like it wasn't just e to the x all the time. We could have things other than just x. If that's the case, then we do use our chain rule. So we would do 1 over u times du dx, the derivative of what's inside. Or you might see it as u prime over u. And don't forget, this is when u is greater than 0. So let's practice. Let's differentiate both of these. I'll start this one, then I'll give you guys a chance to try g of x. Now for this first one, I do have a product, so I have to use my, that's right, product rule. It's the first times the derivative of the second. We just said that the derivative of natural log of x is 1 over x. That's multiplication. Plus the second times the derivative of the first. We could simplify this a little nicer. This would just be natural log of x. Wonderful. Let's have you guys try this second example. Go ahead and put me on pause. So hopefully you guys got 1 over natural log of x all over x squared. How did we get that? Quotient rule, low d high minus high d low, all over low squared. Let's see if we could come up with a calculus musical. How about that? That would be sweet. All right, some more practice. All right, this one, let's take a look. We have the natural log of the square, oops, panic. All right, back to normal. We have the natural log of the square root of x plus 1. Interesting. Well, that derivative, all right, come on, just function with me, please, would be 1 over the square root of x plus 1. But don't forget, we also had to multiply, chain rule, by the derivative of what's here, which is 1/2 x plus 1 to the negative 1/2, chain rule of that, which is just 1. And we could simplify this a little bit nicer. This could be, sure, 1 over 2. Now, when I combine these, I would get it just x plus 1. Cool. Now, notice that these next two are slightly different. Now, the radical is located in a different spot. So I'm going to encourage you guys to try these on your own. Really think about order of operations here. And then we'll go ahead and check together. So go ahead and put me on pause. Alrighty, so now this one, we have the square roots on the outside of the whole function. So that's the part that we have to derive first. So I use my power rule. I multiply by 1/2, reduce the exponent by 1. What's left inside remains the same, and then I multiply by the derivative of the inside. Derivative of natural log is 1 over x, derivative of 1 is 0. I can simplify this a little bit, and la-di-da looks like a beaut. All right. Then this one, notice that the x plus 1 is grouped together. So similar, I do multiply by 1/2, reduce the exponent by 1, keep the inside the same, multiply by the derivative of the inside, which is 1 over x plus 1. I said times 1 just because of the derivative of x plus 1 is 1. Simplified this bad boy, and then I got 1 over 2 times x plus 1, square root of natural log of x plus 1. I know. Super fun. All right, here's another example. Now, you might look at it and you might be intimidated. When we get intimidated, we don't shrivel down in size. We stand up tall, look at it in the face and say, I'm going to get you. I have no idea what that was about. Anyway, we can do this. We can totally do this. So I'm going to encourage you guys to try this one on your own. Here's my hint. Okay, this is the natural log of all of this. Okay, so I know the derivative natural log of something. Don't forget to multiply by the chain of the something. All right, so go ahead, put me on pause. All right, let me give you some facts here. If you just scramble down and copy down all my work on this one, you will not understand it. However, if you pay attention to what I am explaining and follow along, perhaps you will. So please be diligent here. I started off by taking the derivative. I know since it's a natural log, it's 1 over what the log is of, times the derivative of all of this. Now, keep in mind that this is the product rule, right? So it's the first times the derivative of the second, plus the second times the first, okay? Now, this might seem overwhelming to you at first. I get it, but perseverance. Now, I just put all this stuff over this denominator, and I multiplied the 6 and the 3x squared to get this 18x squared here, okay? The rest of it is unchanged, unless I made a mistake, which happens, as you know. All right, next. Now, what can you see that I did from this step to this step? Okay, so I see some brackets, see some things pulled outside. You're right, I did factor out a GCF. Now, I factor it out of 2x from here, and then I factored out a 2x from here, which reduced that to 9x. And notice that I also factored out an x cubed plus 5 to the 5th, x cubed plus 2 to the 5th. I can't talk. Okay, and this is what I had remaining. Now, what's inside here is pretty simple in terms of simplifying, so I multiplied all that out, and now you're wondering, well, what just happened to my term here? Well, it canceled out. One remained in the denominator, okay? These I'm going to collect like terms, and last but not least, multiply out my 2x, and then I'd be done. Now, I do want to inform you that there is an alternate method to do this. Now, remember that this was my original function f of x, and don't forget, when we learned logs long ago, man, logs are fun. We learned how we could expand them. So since this is a product in here, right, I can make this a sum of logs. I could bring the 6 in front. That's my power rule here. And then if I wanted to find the derivative, I could just find the derivative of this term plus the derivative of this term. So there's an alternate way to do it. Whichever one you prefer is totally fine. But just want to reiterate that, you know, these were meaningful for a reason. All right, let's try this one. We're trying to differentiate. Notice that our variable here is t instead of x, which is fine. I have a recommendation for you guys. It would be immensely easier to use properties of logs. So recognize that that's a product. See if you can rewrite g of t first and then take the derivative. So go ahead, put me on pause, and let's see what you got. I hope you guys got a final answer that g prime of t is 2 over t minus 2t. How'd I get that? Well, I gave you the hint. I said that this would be 1,000 times easier if you use your properties of logs. So because I have multiplication, I could turn this into a sum of logs. So this is natural log of t squared plus natural log of e to the negative t squared. From there, hopefully you guys remember this awesome rule, I can bring the exponents to the front of the log. So I did that. But then notice that natural log of e, we know that that's 1, right? It's one of our rules, known fact. So I just take the derivative of 2 natural log of t. Well, that's 2 times 1 over t, which is 2 over t. And then we know the derivative of negative t squared is negative 2t. All right, so in conclusion, today we discussed how to find the derivative of natural log of x. Oops, that was a mistake. Don't forget that it's 1 over x when x is greater than 0. Why is that? Because the domain of natural log of x is when x is greater than 0. We can use the chain rule as well. And also, just to keep in mind, sometimes using properties of logs can help make it easier. Not always, but sometimes.